Here's a look at the last review question for our Unit 9 test review. It says an 800 kilogram car that is being pushed by a truck with a force of 10,000 newtons. The coefficient of friction between the tires and the road is 0.50. The first thing we want to calculate is the weight of the car. Then we want to calculate how large the normal force is on the car. We want to calculate what the force due to friction is, what the net force is, and then finally what the acceleration of the car is. So for the first part, we're going to use Fg equals mg. Our force due to gravity, or our weight, equals the mass times the acceleration due to gravity. So the mass of the car is 800 kilograms, and since we're on Earth, the acceleration due to gravity is 10 meters per second squared. So that's going to give us 8,000 newtons. For number 2, we know that the force due to gravity is the same as the normal force, so that's 8,000 newtons. For number 3, we're going to calculate the friction force by taking the coefficient of friction and multiplying it by the normal force. So 0.50 times 8,000 newtons gives us a friction force of 4,000 newtons. Then we want to calculate the net force on the car, which is taking the applied force of 10,000 newtons, subtracting the force due to friction of 4,000 newtons, and our net force is 6,000 newtons. Finally, we want to calculate what the acceleration of the car will be. So we'll take the net force, which is 6,000 newtons, divide it by the mass of the car, which is 800 kilograms, and that gives us an acceleration of 7.5 meters per second squared. If you want to go back and practice these problems and check your answers again, that would be a good way for you to review for your test tomorrow.